So for this homework, we always deal with mixtures, and these are often specified in terms of total molar flow moles and molar fraction of each component, x1, x2, and xn. So oftentimes these are given values. Sometimes these mole fractions are unknown and exactly what we need to solve for the problem. And we need to typically involve equilibria and reactions and solve for these unknown mole fractions. So what we want to do is we want to do molar flow variable transformations. So we're going to want to convert between v to x, from x to v. So v is like, for x, it's a molar component that is ranging from 0 to 1, as you can see from right here. But v is not like a specified value. But we can use these two equations because instead of solving for the mole fraction directly, we can solve for the transformed variables vi, which have a unconstrained domain ranging from negative infinity to infinity. So if we know each vi, we can calculate all the mole fractions xi, and they automatically satisfy the constraints. So say for like n equals 3, just a 3-component mixture, try any values for v1, v2, and so on. So we're going to be using what Carlos has given us, these two equations. We're going to utilize it. We're going to have some substitution and some, and some algebraic math, just to convert from xn to vi, essentially, v1. So you want to put it in terms, we have I'll show you, actually. So talking about it. So I already wrote down the equations that we need to utilize. So over here, you have xn, x1. So what can we do here to isolate this v1 term and to get rid of this term as well? What can we do? So what we can do is we can actually take the natural log of all of this. Okay, so we can take the ln of x1, and if we multiply this over to this side, I'm multiplying this equation 1 plus e to v1 plus e equals v2 to the other side, and I'm just taking the natural log of it. Okay, you guys can see it? Perfect. Okay. And then we're going to take the natural log of e to the v1. So after looking at this equation, like, we want to isolate what v1 is, because we have our unknowns in this equation, and we have this, and we need to isolate. What could we do? So at first glance, looking at this, we do know the natural log of ln of e is equal to 1, so we can cross that out. And we can also say that v1 is equal to the natural log of x1 multiplied ln 1 plus e to v1 plus e to the v2. Okay, so looking at this equation, what can we do? So to make it easier and come back to it, we can say that this is equal to u. And then we want to implement the other equation from above. So if we said that x1 plus x2 is equal to e v1 plus e v2, 1 plus e v1 plus e v2. So what we could do is we can say, to summarize this, to make this a little easier, let me move this up more. Oh yeah, you can't even see from what I'm doing here. Let me move this up here. Actually, yeah, one second. I want to move. Okay. Yeah, perfect. So where were we? Let me look at this. So we do know that x1 plus x2, we can rewrite that as, I have to go back now. We can say that's equal to x to make it easier, and we can say that's equal to u because we said define that was u, and we can say 1 plus u. Perfect. Yeah, it sees everything. Okay, so what we're going to need to do is we're going to just multiply by both sides. X1 plus u equals u, and then we get x plus xu is equal to x is equal to u, and then we can minus ux, so we get x equals u minus I don't know why I'm getting confused over simple algebra. Trying to do it multiple steps in the head. So we can get left over with that. So what were we trying to essentially do is to get u by itself. So we can u, we divide this over this side, and we get, oh, you guys can't see it. We get u, and we get, oh, no, that's not it. So u, okay, we divide, it's x over 1 minus x. So we're able to get this expression that in terms of u, we're going to substitute everything back because we want to get v of 1 in terms of the x1, x2 values. We don't want the v, which is the, because we're trying to do the molar transformation. And we need to get rid of those terms. So we're going to bring back the equation we had from above, and we're going to just plug everything in. Ln x1 times ln 1 plus, we said that was u. Okay, what is u? 1 plus x, 1 minus x. Okay, looking at this equation, there's one thing we're missing. Think about it. What could we be missing? What could we possibly be missing? Well, as you see from the x, didn't we change that from above? First it was x1 plus x2, we made our lives easier. Now we have to go back and change it back. So now we get v1 equals ln of x1 multiplied by ln 1 plus x1 plus x2 over 1 minus x1 plus x2. And then from there, we were able to get what we were trying to solve for in this problem. So, thank you for watching.